Hello. Hello. We did chapter review A before, and I will go on with the second part here. For now, I will skip the sketching graph. I will do it later. I think it will take some time, so I do it separately after this. I call this sketch. But then let me do this first. Okay, so this covers the optimization and then some Newton's method, which I know some instructors don't really cover or they barely cover. I will go over this and show you how to use calculator and how to use Excel. Okay, and then after that, I hope the later part is the easy part of finding the antiderivative. Okay, so I think this part here will be on the shorter side. Okay, let's start. Number 38. Number 38. Find two positive integers such that the sum of the first and fourth time the second number is 1000. You know what? Let me define first. Let x be the first number and y second. From the passage, we see the relationship that the first number plus 4 times the second number equals to 1000. Okay, so x equals to 1000 minus 4y. Okay, and the product of the numbers is as large as possible. So let's define let function f be the product xy. Notice that it consists of two variables right now, right? So I cannot call that fx, but once I substitute the x, then I will get y 1000 minus 4y. Now this is a function of y. Okay. Now that's the one we need to maximize, huh? Yeah, as large as possible, right? So step 4, I do the first derivative respect to y. That will give me 1000 minus 4y plus y times negative 4. Is it right? Which will give us 1000 minus 8y. If I set that equals to 0, I will get y equals to 125. Now I want to show that this will give us the maximum. So do the sine graph, or you can also do the second derivative. Okay, the sine graph. You know what? Do the second derivative is easier here. So the second derivative is negative 8, which is always negative, which means that's a local maximum. Local maximum at y equals to 125. Okay. Consequently, the x equals to 500 then, huh? Okay. Now then, but you see, we have only one local maximum here, right? Then that would be the absolute maximum. Can I say so? You know, okay, because this function is before 125 for the y, the value is increasing here, right? That's the f prime. F prime y is positive to the left and then negative to the right, which means the 125 will be the absolute maximum. Okay, so summarize that. So those integers are the first one is 500 and second is 500. seconds 125. Duh. Okay, that's for number 38. Number 40. Find the point on the hyperbola xy equals to 8 closest to the point 3, 0. Let's say this is point 3, 0, and that's the curve. Okay, call xy be a point on that curve. So let coordinate step 1, let coordinate xy be a point on the curve xy equals to 8. Now because of that, then we can represent y equals to 8 over x, right? Okay, now then construct a distance formula. In fact, I will just do distance square. Fx is distance squared x, and the distance will be x minus 3 squared plus y minus 0, right? From xy to 3, 0. This is the d here. Okay, so the difference in x is x minus 3. The difference in y is just y, but because I square that, it will be, maybe I write it down, 8 minus x minus 0, 8 over x minus 0 squared. So this will be x minus 3 squared plus 64x to the negative 2. Now then, the first derivative will be 2 times x minus 3 minus 32x to the negative 3. If I set this equals to 0, then I get 2x minus 6 minus 32 over x cubed equals 0. Or maybe I make it equal here. How to do this one? I wonder if I do this right. If I multiply by x cubed, I get 2x to the 4th minus 6x cubed equals to 32. Huh. Did I do anything wrong? Why it looks so ugly? Oh, I can divide by 2 at least, huh? Okay, let's divide by 2 first. I hope that reduced my anxiety. I get anxious now. X to the 4th minus 3x cubed minus 16 equals to 0. You know what? I do synthetic division to check. Say 1, negative 3, degree of 2, degree of 1, degree of 0. When x equals to 1, that's negative 18. How about when x equals to 2? When x equals to 2, that's negative 2. Okay, maybe I change it to x equals to 3 then, or 4. Maybe I try 4. Maybe I try 4. Yeah, I try 4. Because from rational zero theorem, then if we have a rational zero, the zero must be a coefficient of 16 divided by, I'm sorry, a factor of 16 divided by a factor of the leading coefficient 1. So 3 will not be, 4 maybe. Okay, so 1, 4, this is 1, this is 4, this is 4, 16. 1664. Oh, it's a very big number. Huh. I wonder what will that be though. I wonder what will that be. This is what is this? A 48? Positive 48? Am I making a mistake? Distance squared. I'm checking my work. Yeah, I don't see any mistake though. Yeah, I don't see any mistake. Divided by 2. Huh. So how do I get this without working too hard? Hmm. Yeah. I'm sorry. I kind of like a bit anxious now. So 4, 3, 2, 1, constant. Yeah. I don't miss anything. I don't miss anything. So what will this be then? Okay. Uh let's look at this as a function first. So suppose I suppose I call gx equals to, now I want to show you my struggle too. So I'm not someone like I see a problem, I know what to do right away. I try to do it regular way. Okay. I know g1 is negative. G1 is negative 18, and G2, what is that? I believe I tried that earlier. G4 for sure is for positive 48. Okay, but what is G2? Unless I make a very terrible mistake here though. So this is -1, this is -2, -2, -4, -4, -8, so -24. So the answer must be between 2 and 4, huh? The answer must be between 2 and 4. Okay, you know what? I just realized I make a mistake here. Yeah, 8 squared is not 16, it's 64. Duh. That's 64. So this is -128. This is 128. My bad. So this is 128. And then later on I divide by 2. It's 64. So all the numbers changes here. This is 60 minus 64. Minus 64. Okay, 1, 2, negative. This 2, -1, -2, -2, -4, -4, -8, -72. This is -66. How about when x equals to 4? What I'm doing here, I use remainder theorem method from pre-calculus. Yeah, this is the one, huh? Okay, G4 is 0. It means I can factor this with x minus 4 times x cubed plus x squared plus 4x plus 16 equals to 0. The thing is, can I factor that further? I'm not sure. I'm not sure if we can. But, well, it's degree of 3, so it must have a 0 somewhere, right? And because all the coefficient is positive, then the zeros will not be positive. You know the Scatter's rule of sign, right? If the number of positive zeros is the number of times the sign changes, okay, but or if you subtract by 2 or subtract by 4. Here there's no change, so there's no more positive 0. Let's try a negative number, but if I try -1, that will be, let me see, -1. Positive 13. Okay, let's try -2. It must be a factor of 16, right? Let's try -2. Oh, so it must be between -1 and -2 then, huh? Yeah, it must be between -1 and -2. Yeah, another 0 is between -1 and -2. Okay. How do I want to do this? You know what? Let me do the, yeah, I need to find it, the other one. But if I do the second derivative test, this guy becomes 4x cubed minus 9x squared. Is it right? No, I need to use that one, not this fx. My bad. So I need to use this one here. So the derivative will be 2 plus 256 x to the -4, right? And then at 4, that's a positive number, huh? So that's positive number. So this is the local minimum at x equals to 4. But as we see earlier, we have another local minimum at between -1 -2. Between -1 -2, we have another minimum. The y-intercept is -64, and we have yeah, minimum there. How to say that? This is the slope function. Okay, this is the slope function. So we have x-intercept at 4, and then another x-intercept here. Okay, maybe somewhere else, I don't know. It opens, according to this, it opens up. So I think it will be something look like this. Yeah, I think it will be like something like this. Okay, so this will be the only local minimum then. Yeah, negative slope becomes positive slope, right? Okay, so I will say, assuming this is the only one, assuming this is the only local minimum, then the coordinate will be, when x equals to 4, then the y will be 2. The coordinate is 4, 2, is a point on the curve, xy equals to 8, closest to 3, 0. Okay. More thing to say though. How about the one here? The way I detect that, I know that it will be between -2 and -1, and when I plug that in, that's also positive, huh? That's also positive. The second derivative is also positive. So that's a local minimum also, huh? That's a local minimum also. So this may not be the correct graph. I have to erase this one. This may not be the correct graph. I know here is yeah, it changed from negative becomes positive, right? But between -2 and -1, not sure. I'm not sure. Let's say it that way. So it could be another coordinate. Let me think about how to find it. Okay, let me think about how to find it. So basically, what I'm about to do now is to solve this. I get one of the zeros, right? I get one of the zeros, but we know because this is degree of 3, then we must have another real zero. Okay, at least one more real zero because the range is all real numbers. Okay, and according to the way I did it earlier, let me show you again. So my f -1, f prime -1, I mean this guy here. So that's 1, -1, 0, -1, 3, -3. That's positive 13. right? So if I call, what is that, gx maybe equals to x cubed plus x squared plus 4x plus 16, unless I did anything wrong there, but I don't think so. Then g negative 1 is 13, but how about g negative 2? Huh? Did I count it wrong earlier? What happened? What happened with me? Negative 2, that's negative 1, that's 2, 6, negative 12, that's 4. So no, there's nothing between. G negative 2 is positive 4. How about G3 then? Or G4 maybe? How about G4? G negative 4, I mean. This is 16, negative 64. Yeah, that's very negative already. Okay, how about 3? Apology. Yeah, so what happened is between negative 3 and negative 2, we have roots there, right? Between negative 3 and negative 2, we have a root. But the second derivative is also is also positive from here, from what I see here. The second derivative is also positive. So that's a local minimum also. There, yeah, oh, it's a local minimum also. I don't know what number is that though. I honestly don't know how to what's the number there. Let's do Newton's method then. Okay? Yeah. So at least I get the solution, one solution already. I get one solution already. Okay. There could be another point that is, you know what? Let's compute. What is the distance? The distance with the distance from 4, 2 on that curve and 3, 0 is square root of 5, huh? 1 squared, 2 squared is square root of 5. Is there any way to be closer than that? Let's see. We don't know. Let's see. We don't know. Now I will apply Newton's method right now. So let me erase this first. According to intermediate value theorem, we know that there is a 0 between negative 3 and negative 2. Okay. Now I know I have not mentioned Newton's method here in my review, but let me show you one way to apply that. Okay. By intermediate value theorem, there is, the way I showed it earlier, there is a 0 between negative 3 and negative 2 of gx, right? Okay. So we assume, no, we don't assume. We do the following. Notice that if we do the Newton's method, then the zeros in the next candidate zeros, the next approximation is the current approximation minus f xn over f prime xn. I wonder if you can take a look later on when I go over this, okay, in the later question. Now, I'm sorry. So in this case, it's g, not f. So g prime x is 3x squared plus 2x plus 4. Okay, now then let's choose a number where we estimate that from. Okay, it's between -3 and -2, right? Let's choose some number in the middle, -2.5. Okay, so let's say my x0 is -2.5, then my x1 will be -2.5 minus g of -2.5 over g prime of -2.5. Okay, and then later on, whatever my x1 is, I use that in my x2, and I use that in my x3. Plug in the same formula. Okay, now I will use my Excel. Let me show you. I will use Excel. Let me move to Excel page here. But you can also should I just use I use calculator. I use calculator. Give me a second. Where's my calculator? I used TI-84 though, so I use my calculator. Okay, so let me plug in -2.5 as my first input. Okay, now then that's my x0, right? My x1 will be that answer minus parenthesis. Now for the numerator, I plug in g -25, which is whatever that answer to the power of 3. Okay, that's my gx, right? Plus whatever that answer squared. Oh, I have the square here. And then plus 4x, 4 times that answer, plus 16. Notice I purposely don't plug in -2.5 because I want to use this formula in the next step. Okay, I want to use this formula in the next step. Divided by parentheses, the derivative is 3 times that answer squared plus 2 times that answer plus 4 close parentheses. This is the answer. Okay, let me do it again. Use the same entry. Again. Use the same entry. Again. Okay, so from here we see we get the, so x1 is -2.30986. -2.30986. Okay, and then x2 will be -2.29503. -2.29503. And then the next one, -2.29495. -2.29495. Actually, if you want to be close to 5 decimal places, let's do one or two more times. Eh, yeah. What did I do? I supposed to use entry. I missed it already. I need to type everything over again. Can I go back? Can I go back up there? Yeah, so use entry here. Use that entry. Can I? No, I cannot anymore, huh? Delete. Okay, then go to the next one. Entry. Enter. Yeah, it's already to accurate to actually 8 decimal places. Yeah, that's so 2949758. 4758. That's already accurate to this number. Okay, but the thing is, if this is our approximation for the other zeros here, then my y3 correspond to that will be 8 over that number, right? Okay, And I think the problem is the distance. The distance from negative 2.29495, let's say, comma, negative 3 something from here. The distance between this number and 3 comma 0, it's already greater than 5, greater than radical 5. Okay, so that this coordinate may be a local minimum, okay, but not the absolute minimum. Okay, and actually if we take a look on the graph also, if you happen to know the graph, which I supposed to do earlier, so we have this guy, right? Okay, and then 3 comma 0 must be here. Okay, so it won't be in quadrant in the it won't be in quadrant 3. The answer has to be in quadrant 1, right? Okay, so once we get, so maybe I cut it here, I cut it here, I cut it here. Okay, because we can then argue x cubed plus x squared plus 4x plus 16 has no positive root by Descartes' rule of sign. That's why we just talk about x equals to 4. And when we do the second derivative test, we found that's a local minimum at that x equals to 4, then therefore that's the closest, right? Okay, if we draw that earlier, okay, then we basically exhaust the possibility of getting the closest point in quadrant 3. It won't happen. It won't happen. Okay. Now that's for number 40. It seems like I work too much, but notice that my mistake is like I didn't graph that first. Then I should have saved a lot of time if I did. Okay. But at the same time, then I have a chance to show you unintentionally show you how to use Newton's method, right? To solve that, to solve a zero. Okay, let's go on. The velocity of a wave of length L in deep water is given by this function, okay, where K, C are known positive constant. What is the length of the wave that gives minimum velocity? Well, minimum velocity, we need to get the phi prime first, okay? As a function of L, this is K times L over C plus C over L to the power of 1/2, where K and C are constant, so the derivative will be still K times 1/2 times the derivative of times L over C plus C over L to the power of negative 1/2 times the derivative of that, that's 1 over C minus C over L squared. C are positive constants. So now this has critical number when 1 over C minus C over L squared equals to 0, or L over C plus C over L equals to 0. The denominator give us 0, right? Okay, but this will give us L equals to C, right? Okay, 1 over C equals to C over L squared. So L squared equals to C squared. So L will be equals to plus or minus C. Okay. Let's see, maybe positive, maybe negative. Oh, C is positive constant, but L may be negative. Now, that's according to what we have there. On the other hand, L over C equals to negative C over L. So L squared equals to negative C squared. But no, L squared has to be a positive number, right? L squared has to be a positive, I mean, greater or equals to 0. But at the same time, that contradicts with the fact that C is a positive number. It's not 0. Okay, you see, a positive number equals to negative number. The only time it can happen is when that number is 0, right? Okay, but that contradicts with the fact that they say C is a positive number. If C is a positive number, then C squared cannot be 0, right? Okay, which means L squared cannot be a negative number. Well, if this is true, then L squared is a negative number, but it's impossible. L squared by nature at least 0. Okay? Now, so we only have these two possible value here, which comes from this guy, right? So let's do the sign graph. We want to make sure we get the minimum velocity. Okay, 0, and then this is negative for the L. This is negative C, this is positive C. Okay, I think we will we will notice that if L is greater than C, then this becomes smaller. Huh? Is it right? Am I right? So if L is greater than C, C over L squared. If L is greater than C, what happened with L squared? Yeah, I want to say that this is negative here. This is positive. And this is 0 is not the critical, and then this is negative. So the minimum will be at negative C, huh? What is the length of the wave? But the length has to be positive value. I make a mistake here. The L is a length, right? L is a length, so it has to be positive. L has to be positive. So that way we avoid the length to be on the negative side, so I don't need to worry about this. And I will just use C, L equals to C because it's a positive number. Okay, and I don't need to worry about this part here because when I compute it won't happen. The thing is, you know what? I wonder if this is a correct one. So 1 over C minus C over L squared. If L is greater than C, means C over L squared is less than, this is less than C over C squared, right? Which is 1 over C. Which means 1 over C minus C over L squared is positive. Oh, so this is positive. Now that makes sense. I make a miscomputation there. This is negative. Now from here we see that local minimum at that's local mean at L equals to C. Okay, so the work is short, huh? It's just like, notice that I rush into my first derivative. I didn't first say, hey, you know what, this is my equation, and because L is length, then L has to be positive, right? Okay. Yeah, and they give me, and I did some computation also. Okay, let's go on. Let's go on. Hockey team plays in an arena that seats 15,000 spectators. With the ticket price set at 12, the average attendance is 11,000. So if the price is 12, the attendance, call that X, equals to 11,000. If we increase by X dollars, so 12, if the price is 12 plus X, I'm sorry, attendance, call this A then, attendance. if the price is 12 plus X, then the attendance will increase by, no, actually, if the price is lower by X, so minus X instead, where X of course is a positive number, then the average attendance increased by 1,000 per $1, right? So 1,000 plus 11,000 plus 1,000X. So every $1 we reduce, so let's say X equals to 1, then the attendance will increase by 1,000, right? But there's a limitation. The total attendance is at most 15,000. Okay? Yeah, the attendance is at most 15,000. Now, how should the owners of the team set the ticket price to maximize the revenue? The revenue function equals to the price times the attendance. How many people attend times how much each of them pay, which is 12 minus X times 11,000 plus 1,000X. Okay? That's the revenue function. Now we want to maximize this, and it makes sense because if we FOIL this, we get negative 1,000x squared, right? So it's a parabola facing down. Actually, if that's the case, hold on. If that's the case, I can just solve this using algebra, right? Yeah, because the parabola upside down, so I just need to find the x-intercepts. The x-intercepts are 12 and negative 11. Is it right? So somewhere in between. Okay, but let's use derivative. So so 1 p the price and a is the attendance. Okay, with the limitation is at most 15,000, and of course at least 0, right? The attendance has to be 0. Price also have to be positive. Okay, and then from here we get the function relating p and a, and this is the function we need to maximize, right? And then step 4, the derivative will be negative 1 times 11,000 plus 1,000 x plus 12 minus x times 1,000, which will give us negative 2,000 x plus 1,000. If I set this equals to 0, I get x equals to just 1/2, huh? Yeah, yeah, 0.5. Is it right? So so what is the ticket price? Maximum, and we can see the second derivative also, but you see the second derivative is negative for any x, which means the graph is concave up, so that's local minimum when x equals to 0.5. Okay, therefore the price for maximum revenue is so you reduce the price by $0.50. So $12 minus 0.5, that's $11.50. That's the one give us the best revenue, the maximum revenue. Okay. Now number 49 and on, we use Newton's method. Okay. Now one of the key steps in Newton's method is you need to define the function first and set it equals to 0. In this case, they already give it to us. This is the polynomial, set it equals to 0, but you need to explicitly say that fx equal to x to the 5th minus x to the 4th plus 3x squared minus 3x minus 2. Now they tell us that there's a solution between 1 and 2, and it must be done. You can check that using intermediate value theorem. Okay, yeah. Now the derivative is 5x to the fourth minus 4x cubed. Am I missing something? Oh, no, cube. So plus 6x minus 3. Okay, we will use the initial point 1.5, but you can choose any number between 1 and 2. Let's call x0, the initial point is 1.5. Down our xn plus 1, the next number is the current number, minus f prime xn over f of xn. Okay, now let's take a look on I use Excel this time. I wonder that's what my screen showing. Okay. Let me copy paste that first then. Let me copy it paste this so that I don't need to keep on referring to it. Now then, yes, my initial number is 1.5. Okay, that's initial. The iteration 1 will be, let me enlarge this. That's equals to whatever number we have there, minus parentheses f prime xn. So f prime xn is 5 times whatever number you have there to the power of 4 minus 4 times whatever number you have there cube plus 6 times whatever number you have there minus 3. Oh no, I don't think that's the formula. I don't think that's the formula. The formula is supposed to be fxn over f prime. No, I type it. I write it wrong. I write it wrong. So it should be f on the top and then f prime at the bottom. Okay, let me correct what I have here. So this should be. Oh, this is incorrect. Okay, this is incorrect. You know what? Let me change that. Yeah, it should be this one. Okay, but this is on the numerator, supposed to be on the denominator. So on the top, that will be whatever d5 we have to the power of 5 minus whatever x to the power of 4 plus 3 times that x to the power of 2 minus 3 times whatever that x minus 2 close parenthesis divided by the denominator. Now let's check. So xn minus the numerator x to the 5th minus x to the 4th plus 3x squared minus 3x minus 2 divided by the derivative 5x to the 4th minus 4x cubed plus 6x minus 3. Okay, let me press enter. I hope I don't write anything wrong. Okay, so this is the first iteration, right? Now then you can copy paste this thing all the way, and we can stop once the number how many decimal places you need. Iteration 2 here, and notice that up to the 5th iteration we already get the same number, so we don't need to go far, huh? Let me copy that back here. Boom. Okay, so correct to 6 decimal places. In fact, I am correct to 9 decimal places, right? To 6 decimal places. Yeah, actually iteration 4 is close to 6 decimal places already. Okay, so that's the number. That's the answer. That's the answer. That's the root. Okay, so x equals to 1.2973834 0.03. Wow. Amazing, huh? It goes that far? Okay, number 50. Number 50. So you see the procedure is the same, right? So we let fx equals to sine x minus x squared plus 3x minus 1. This is the one that we want to make it 0, right? We want to make it 0. Okay, then the first derivative is cosine x minus 2x plus 3. They don't tell us where is it, where the interval though. Huh. Yeah, they don't tell us the interval. That's a bit challenging. So let's find f0 then. f0 equals to -1, and f pi over 2 will be 1 minus pi over 2 squared plus 3 times pi over 2 minus 1. I think this should be positive. Yeah, this is positive. This is positive. Right? Yeah, that's positive. Okay, so between 0 and pi, there is between 0 and pi over 2, there is a solution. The value here is negative, the value is positive here, then it's a solution here. Okay, now the thing is, this function is opens up and it may oscillate. So it may hit it at most twice. Yeah, I think it hit it at most twice. I need to graph them properly though. You know what? Let me do it. Let me do it. So if I go back here, x squared minus 3x plus 1 is x squared minus 3x 1.5, 2.25. So this is x minus 1.5 squared minus 1.25. Okay, now the thing is like the value of sine is at most 1, at least 1, at least -1. So this is the graph, the sine graph. And then 1.5 is approximately here, 1.25. So it opens up like this. So there should be another solution in the negative side, huh? So we have one between 0 and pi over 2. Sine x. Hold on. So it seems like there's one here and then there's another one there. Yeah. Okay, so yeah, the reason I do completing a square on the one on the right hand side, so that I try to sketch the graph basically without using the graphing software. Okay, but it seems like something not really right there. I did the derivative correctly already. Yeah, we know that one of them is between this gives us 0 positive. Between 0 and pi over 2. You know why I get confused? Because according to the graph, sine x should look like this, right? This is sine x. Okay, this is pi over 2 here. Okay, now 1.5 is slightly to the left of that, and the graph looks like this then, huh? When x equals to 0. Oh yeah, so it looks like this. Okay, so it seems like it intersect another intersection between pi over 2 and pi. Let's see, f pi equals to what? F pi equals to 0 minus pi squared plus 3 pi minus 1. Yeah, this guy is negative already, right? So this is negative. Yeah, so there's another 0 here. So C2 here and C1 here. Okay, okay. So we have one, and there's no more, right? There's no more there's no more intersection, only both of these. Now, what we're gonna do then, I will use a number between 0 and pi over 2 and another number between pi over 2 and pi. Okay, let's go back to our Excel file. Oh, Excel file is here. I use number 50, make it smaller. Yeah, I use maybe initial number 1, but hold on, I need to fix this though. So it will be D8, and then the numerator is, notice that the X here is in radian, so it's safe for me, and Excel actually recognize radian, so that will be sine X, close parenthesis, minus X squared plus 3 times X minus 1, that's the fx, right? Divided by f prime x, which is cosine x minus 2 times that x plus 3. Now, then I need to copy this function though. Okay, so this is the number I have. But this one is between, between 0 and pi over 2. Okay, now but if I use between pi over 2 and pi, let me copy paste this thing. Of course I need to make sure that I keep the formula though. Okay, now choose a number between pi over 2 and pi. Maybe 2, right? Yeah, pi is 3.14 divided by 2 is around 1.5. Pi is 3.14, so I can choose a number 2. Okay, so these are the answers. Put it back here. So those are the solutions. Okay, those are the solutions. Let me go to 5th iteration because they are actually accurate to the 5th or even 6th decimal place already if I round, right? Okay, so yeah, so those are the two numbers. You know what? Let's try to sketch the graph. So I have the graph of sine x minus, what's the function again? I forgot. Minus x squared plus 3x minus 1. Minus x squared plus 3x minus 1. Is that the function that we're looking at? It just looked like that. Unexpected. I don't expect that though. I really don't expect that. But from this graph here, let's trace it. Yeah, let's trace it. You see when when the y equals to 0, the x is 0.268881. Is that what we get? Yeah, 268881, right? Okay, and then the other x-intercept, okay, 2.77006. Now the thing is, this only accurate to 5 decimal places though. 2.77006. Is it what we have? Yeah, 2.77006. Right? We are actually even more accurate. Okay. Let me go on with the last one. I hope at this point you already see, oh, you know what? How do we do Newton's method? Okay. So first, the procedure basically, you take that. Let me do number 51 again, but I hope you can see the procedure. Okay, the fx is set it equals to 0. So here you have that function. They tell you the function cosine t plus t minus t squared. Okay, and you want that. Oh, you want the absolute maximum correct to 8th decimal place. So this is absolute maximum if the first derivative is equal 0 and second derivative. Oh, so we are not solving this. Do the first derivative and set this equals to 0. Okay, negative sine t plus 1 minus 2t. That's the one we solve equals to 0. Right? Okay, that's the one we need to solve. That's the one we need to solve. Let's do estimation then. F prime 0 equals to 1 and f prime pi over 2 equals to negative pi, right? So f prime equals c equals to 0 for a number c in the interval from 0 to pi over 2. Okay, and as you can see, this is a linear function, right? So at one point it becomes positive. I believe we will have only one zeros, right? I mean, this is quadratic, right? This is quadratic, and this is at most one, at least one. So we have only one local maximum, at most two, but I don't expect that. Yeah. So this is the function that we need to solve, find the root, right? Okay, so what is g prime x that we will use in our Newtons later on? That will be negative cosine t minus 2. Okay, so our formula later on will be xn plus 1 equals to xn minus gx, which is negative sine t plus 1 minus 2t over g prime x, that's negative cosine t minus 2. Okay, you know what? Let me divide the top and the bottom by cancel the negative. So that will be sine t minus 1 plus 2t over cosine t plus 2. Okay, that's the one I will use. Bring to my Excel. Cancel this one. Move this one up. And I don't need this anymore. I need to fix this. So what is the number that we can use again? It's between 0 and pi over 2. Yeah, 1 is good. 1 is a good candidate, but I need to fix the function though. So that will be d8, and then the numerator will be sine d8 minus 1 minus 1 plus 2 times t. That's for the numerator. The denominator, oops, the denominator is cosine that plus 2. Okay, and then from here copy paste. Oh, that converges really fast, huh? Yeah, it converges really fast up to the 5th iteration. In fact, notice that the 3rd iteration gives us the number we want already. Yeah, let me put it here. They want what? 8 decimal places? Do we have 8 decimal places? Yeah, we have 9 decimal places. Okay, we have 9 decimal places. So that's the answer. Okay, so t equals to 0.3354180 is gives ft maximum. I use a wrong notation, should be t, not x. Okay, now that's for the Newton's method. You want to look at the graph? Let's look at the graph. Okay, cosine t plus t minus t squared, right? Look at the graph. Cosine x minus x minus x squared. Is that minus x squared? Is that the function? Let me see again. Plus x minus t squared. Plus x minus t squared. Where am I? Plus x minus t squared. So this is plus x. Call this y. You see we have local maximum, right? It is maximum here, approximately, right? Approximately. What number do we get? We get different number though. 0.33 something. Where is that? Oh yeah, my x is 0.33 something, right? My x is 0.33 something. I wonder if you can see that. Yeah. Okay. Well, anyway, that's for the Newton method. The rest, I hope you find it to be Mickey Mouse, but let's just do it fast then. Yeah, so number 53, find the most general antiderivative. Number 53, fx is, let me rewrite that into rational exponent right away. So the antiderivative will be, I add the x, the exponent first, and then multiply the coefficient by that reciprocal. Okay, so this is 6 over 3x cubed plus 3x plus constant. Of course, make it nicer. 8 over 3x 3 half minus 2x cubed plus 3x plus c. Number 54, gx equals to cosine x plus 2 secant squared x. Memorization, right? So the antiderivative is sine x. The derivative of sine is cosine, and the derivative of tangent is secant squared. Number 55. Okay, ht equals to t to the negative 3 plus 5 sine t. The antiderivative will be negative 1/2 t to the negative 2 minus 5 cosine t plus constant. Number 56, fx equals to that. You know what I will do is I split them up. So this is x to the 3x cubed minus 4 plus x to the negative 2. Okay, because the denominator only one term, right? So I split them and then I do the antiderivative. Okay, so that's x to the 4th, 3/4, right? Minus 4x, and then negative negative 1, x to the negative 1. Okay, or we can write that as 3 over 4x to the 4th minus 4x minus 1 over x. Oh, don't forget plus constant. Okay, that's for the most general antiderivative. Number 57, 58, they give us initial value. So after we get the antiderivative, like f prime t equals to that, so ft equals to t squared plus 3 cosine t plus constant. Now then f0 equals to 5, but when t equals to 0, we get this. Consequently, c is equals to 2. So ft is t squared plus 3 cosine t plus 2. Okay, number 58. Fu, oh, this is u plus u to the power of negative 1/2. So Fu is 1/2 u squared plus 2u to the power of 1/2 plus constant with F1 equals to 3. This is 1/2 plus 2 plus c. So consequently, we see c equals to 1/2. So Fu equals to 1/2 u squared plus 2u to the 1/2 plus 1/2. Okay, that's for number 58. Not too hard, right? Number 59, let me steal the place here. So f prime x equals to x minus 3x squared plus 16x cubed plus constant. Call this C1. Now we know that f prime 0 is equals to 2, but if you plug in 0 there, you get just C1. So f prime x equals to x minus 3x squared plus 16x cubed plus 2. Now do antiderivative again. Give us 1/2 x squared minus x cubed plus 4x to the 4th plus c0. I'm sorry, plus 2x plus c0. Now then f0 is 1. So what is this? Negative 1/5.5. 5.5 plus c0 is 1. So c0 is negative 4.5. Am I right? I hope I don't miscompute that. Six, 5.5. Yeah, so fx, therefore, fx equals to 1/2 x squared minus x cubed plus 4x to the 4th plus 2x minus 4.5. Okay, number 60, f prime x equals to 5 over 4x to the 4th plus 2x cubed plus 2x plus c1. And then, oh, they don't tell us f prime, huh? So we need to go on from here. So fx, therefore, equals to, that's 1/4 x to the 5th plus 2/4 x to the 4th plus x squared plus c1x plus c0. Dang. Okay, f0 equals to 3. f0 equals to 3, but that's equals to the constant, right? Okay, so c0 is constant. It's 3. Okay, and then consequently, so for now, fx that we know is 1/4 x to the 5th plus 1/2 x to the 4th plus x squared. Am I missing something? Yeah, missing squared there, huh? And then x squared plus c1x plus 3. At the same time, f1 is negative 2. f1 is negative 2, but negative 2 equals to 1/4 plus 1/2 plus 1 plus c1 plus 3. 3/4, that's 4 and 3/4 plus C1. That is negative, so C1 is negative 2 3/4, right? Which is negative 15/4. So fx is 1/4 x to the 5th plus 1/2 x to the 4th plus x squared minus 15, no, not 15, 11. 11/4x plus 3. That's for number 60. Let's go on. I think that's these two are the last ones. The same thing, right? A particle is moving along a straight line with the given data. Find the position, right? A position function of a particle is the antiderivative of the velocity function. Okay, now because S0 equals to 3 plus constant. So this is 1 plus c, so consequently c equals to 2. So the position function is t squared plus cosine t plus c. I'm sorry, plus 2. While number 62, oh, this is acceleration, huh? So the velocity is negative cosine t plus 3 sine t plus c1. Okay, velocity at time 0 is negative 1 plus 0 plus c1. That is equals to 2. So c1 equals to 3. Hence, therefore, at this time, phi t equals to negative cosine t plus 3 sine t plus 3. Okay, now then from there we go on further. What is the position function? As t equals to negative sine t minus 3 cosine t plus 3t plus constant. Yeah, you do antiderivative, right? Okay, and then from there you check again, S0 is 0. So from there we see that C0 is 3. So the position function must be negative sine t minus 3 cosine t plus 3t plus 3. Okay, now that's for the chapter 3 review, the second part without sketching. I think I will do this. I will do the sketching in other time, but I know that will take longer time. So here we are.